I can give a bit of context at first, but I mean, for this presentation, I think it would be really good if we keep it as interactive as possible. Otherwise, it would just be me walking through some code and examples, and yeah, I mean, it would be very one way. But on the other hand, I really genuinely haven't prepared anything. Like I'm just gonna explain what I've been doing, and so it's best if you ask questions. So yeah, it's a tool that I made toward the beginning of Kusama, not called offline fragment. At the time, the situation was that, so we did this with Kusama, we're going to do it with Polkadot as well, where we enable staking at the beginning, but the rest of the modules would not work. And so people can say that they want to be validators, people can say who they're going to vote for, but the election won't happen. And there's this one click that we called like NPOS enablement. And then suddenly this chain goes into a real decentralized manner, and the Web3 Foundation authorities will be replaced by the real validators and authorities that people get to choose. This is a part of the rollout phase that we had for Kusama, and we're going to have for Polkadot as well. And the situation was that someone just told me, hey, it would be cool if we could know who's going to be the winners of this first election round. And then I made a tool which scrapes the status of, like, reads some data from, I mean, it's hard to say any substrate chain because it's really fragile and it breaks. I mean, yeah, hypothetically any substrate chain. And yeah, it reads, at first it just read these data from staking and ran the same election algorithm, which is called fragment, and run it offline. So I called it offline fragment at the time. This is the main context of what's going on. And so this tool has ever since not really evolved much, but recently I wanted to give it like another push again so that it would be in good shape before Polkadot. I think still some people might use it. I think it's good to play around with, and it also provides some good wrappers around the storage layer of Kusama or any substrate chain. And you can easily like add a script that does something else. And I'm hoping if today we have the time, we can maybe do that. Like there are tons of ideas I have that you can implement with such a tool. And it's no longer really about fragment or being offline. I mean, we're basically just reading state from Kusama, and we're doing some stuff with it. And I do this in Rust. This is probably the main difference from, you can do the same with Polkadot.js API. We're basically doing the same. The only difference is some stuff are really not available there, like the fragment implementation. We don't have that in JavaScript at all. And some cases are easier to handle as well from Rust. Like you have the types in your Rust crates, and when you want to decode them, you just import them from Substrate, and then you decode them. Like it makes things sometimes a bit easier, but it can also be reversed. Like I was just talking to Jaco about what to do about old data, and it could be a mess. So that's, I think, the context.
So this is a CLI tool or something to that effect that I can run at any time, at least unless the types change, and scrape off the state of the chain and get all the amounts that are currently staked. And can I pretend to stake myself to see where I would end up in the election?
Currently it doesn't. Well, that's one of the tools that we can build, and it would be super nice. I haven't done it yet, but yeah, we can totally do that. I don't do that yet, but we definitely can do that here.
Cool. I had just a question too. Is it, so I know you said like we could do some of this in JavaScript, and that's like parts of it are a pretty well-trodden path. Like I know just from my experience, the part about like scraping data from the chain is like pretty easy with Polkadot API.
Yeah, it's super easy.
But then I think maybe what you were saying is like, if we wanted to build this whole tool in JavaScript, we would have to like re-implement all of the election mechanism and everything in JavaScript. And since you've built it in Rust, we actually don't have to re-implement it. We can just, it's like, it's already written in Rust to go.
Yeah. That makes some things easier. And if you take election apart, honestly, it's kind of pointless to build it in Rust. Although I would probably still do it because I also learned quite a lot about Substrate, particularly when I built this. And I'll get to that. I'll try to maybe share some of that as well. But yeah, so if you really just want to read state, and I mean, you can technically also do it in Substrate. Sorry, you can also do it in JavaScript as well. There's yeah, there's not much different. So
I have one more
I guess.
question. So
yeah,
what,
sure.
like I know you were saying it's like designed basically with Polkadot and Kusama in mind, but it should work like with, you know, other substrate chains and stuff. Obviously, like there are some assumptions about what palettes are included in the runtime and stuff like that. So like, do we need staking? Do we need other stuff?
I'm sorry, I saw this and I got sorry.
Yeah, no problem. My question was like, what if I want to use this on like my own homebrewed substrate chain? What palettes does it assume? I assume it like needs staking. Is there anything else?
I mean, you can use it on any chain, but you would probably have to diagnose some stuff manually. It's not really mature yet to that extent to handle anything dynamic for you. Anything that you, for example, get on metadata, you just don't assume it. All the primitive types, like what's the account ID, what's the extrinsic format, what's the block type, I currently just hard code them. Like I don't hard code them, I import them from the Kusama. I import them from Polkadot branch, currently on master, but yeah, technically from Kusama. And if you want to use it on your chain, if any of them differ, you should probably import it differently. And then you have to be lucky enough for everything to work with these versions of substrate. It's not easy to really work. Like I would be very happy if at some point it works with both Kusama and Polkadot, and that would already be, I think, good enough, like, or a pretty good achievement. Other than that, yeah, it can work with any chain, but you probably need some tweaking. Like it wouldn't be trivial, but it wouldn't be too hard either. Cool. Okay. This thing came here. Yeah. So currently, I have 3 commands that you can run, which sort of divide the main things that you can do. 2 of them go about the council and staking, which are the 2 main places in which we run fragment typically. And I also made like a playground recently, which runs any script that you put on some file. So if you want to play around today, we can do that. Okay, let's maybe run something from staking, or let's first see what are the features that we get, for example, from the staking subcommand. Well, there's an experimental feature which I haven't really finished, which checks the results that you get here off-chain with whatever is now on Kusama. And this is, again, something that people have requested quite a lot, but I haven't gotten it right yet. It should technically work, but it would be very hard. But it would be helpful, because if this works, then we know for sure that this tool is predicting everything correctly, and then we can use it for prediction with more confidence. I mean, you can also use it now for prediction. That's most of the reasons that people come to me about this tool. They all want to predict the next round and maximize reward. That's 95% of the incentive. But so this is related to that. Other than that, you can change the number of people that get elected. This is helpful. Many people come and ask, like, I'm in the waiting list. When am I going to get elected? Like, when will I get a chance? Where you can increase the count. Or currently, I think in Kusama, these also always default to the current value on chain. For example, the number of validators is stored somewhere on chain. If you don't pass this flag, we use that. Else, you can override it. So you can increase this gradually, for example, and see when you get elected. Again, I don't promise at the moment that whatever this tool is predicting is 100% the same with what you're going to see on chain, for reasons that I can explain if someone wants to know, but it would be a bit more about the off-chain fragment stuff. But it would be very close. It would be fairly close, I can say. We also know that, well, maybe it's helpful actually if I now explain what happens now on chain. So how do we elect validators now in Kusama? We first run an algorithm called sequential fragment. Predictable, easy peasy, where this name comes from. Yeah, not that complicated. Then we run rounds, like a iterative algorithm on top of it, which tries to make everything balance, which we call equalize. And this is what you can configure here with this iterations of equalizing. And then the thing is, at the moment, our validators are submitting these election results back to the chain with that whole off-chain scheme that I don't want to get into. But the point is, they run a random number of iterations that we don't know. So it's technically kind of hard to exactly know what is going to be the results on chain, because you cannot know which results from which validator is the best one that we have at the moment. Yeah, this can also be configured. I'm gonna probably run a few examples here. And back to the pipeline. So you run sequential fragment, you run equalize, then you run another algorithm called reduce. Again, I explained it in a different talk and a different seminar a few weeks ago. It shrinks the size of the solution. You can also try that here, so you can see how a reduced and an unreduced solution differ. Lots of people were also confused about this in the validator community, because this reduce changes quite a lot of stuff, but at the end of the day, it doesn't actually change the status of the validators, but it changed nominations quite a lot. And yeah, and finally, you can also have the output dumped to JSON. This is not really, I mean, it may be useful. Anyhow, enough talking. Let's run something. I think that's more interesting than me just talking.
David, did you have a question at some point? I thought I saw you.
Yeah, if someone has a question, always ask.
What is the source of randomness for the validator to pick how many rounds they run?
It comes from the chain, like that piece of code is executed off-chain in staking code, and the off-chain worker API actually gives a random seed, which I don't know where it comes from, but I guess, yeah.
But it's not one of those fancy verifiable delay functions.
No. It's nothing like that.
Got it.
Also, like who runs this? Like, so is it every validator will run through those iterations of that?
Every validator runs that, but they are smart enough not, so every validator runs it, but they're not allowed to submit it back unless if they are authoring a block. And when they are authoring a block, they look if there's already a solution on chain, and they check if the one that they have local has a better score. If it has a better score, they submit it. Else, they don't. And I mean, this is how it's supposed to work. I hope that's actually how it works. But yeah, this is the overall.
So is it the case that it's always each validator, or is it also, like, I know in general you can run an off-chain worker on your full node if you just give it the right flags, like you can say, like, I know I'm not a validator, but run it anyway. Is that the case here as well?
You can run it, but you wouldn't, like, you can run an off-chain worker, yeah, then you would do all these computation, but you would never be allowed to submit it.
Okay,
because
so pretty much a waste of time to do that.
Yeah, I mean, you can do it if you want. But yeah, you wouldn't be allowed to submit it. So the results that you get by default is just, I mean, I run it now with no command, no flags. So we get the 220, oh, we already bumped to 250. Things are moving quite fast. Okay, yeah, we get the 250 validators. This, don't even try and compare it to Kusama, I would say, because it's a lot different. You get some status, which is nice to look at. I mean, number of total validators, you have that in Polkadot.js as well. The rate of all tokens that are staked, something which I added mostly for my own experiments. The size of this solution, like if you want to encode this and submit it back to the chain with all these procedures that we talked about, this one is now what, like 200K? 200 kilobytes, yeah. And then we have the compact size, which is the one which has all the reduce and all the optimizations that we have, which is only 6 kilobytes. This is only for my own diagnostics. What else? For each validator, you get you get their rank, sort of, because Fragment is choosing them in a sequence of, like, they are chosen one by one. If you run the same thing, but you give it like 249, you get exactly the first, like the first 249 would be exactly the same, and the last guy would be cut out. Like at least that's how it's supposed to work. You also get the total amount that is been backed for each validator, like their own stake and the sum of all the stake that they're getting from all of the nominators, number of voters. I have to, okay. Number of voters and which portion of it comes from themselves. So let's look at, I don't know, this guy, whoever that is. In total, lots of stake, 15,000. Only 1 KSM of it comes from themselves, and the rest comes from these 3, I guess, very wealthy nominators. You can always increase the log levels here, like you would get, and then you would get more insight. Okay, this V needs to come before staking. But then it gets kind of messy as well. Like it gets then too much stuff. I usually pipe it to a file, but that's fine. I mean, we were now talking about, yeah, I guess maybe it was this guy. No, I don't know. Yeah, if you increase the log level, you get more and more info out of it. Look, for example, you can see how you basically get the same output as you were getting before, but now you also get the exact distribution of voters as well. Like when we said this guy had 25 voters, who were those 25 and how much did each of them contribute? Which is basically just untangling how Fragment is working under the hood. We're building this graph of nominators to validators and like a flow of stake in between them. What else? I think if you put like -v one more time, then you get really a lot more information. And then you get the reverse of the same info as well. So for each nominator, you get well, yeah, I really should have put this in a file. Okay. For each nominator, you also get a distribution. How much stake are they giving to each of the validators? So you basically get the reverse of the previous thing as well. So in this case, yeah, we first got like all the 250 validators, and then for each of the 900 something nominators, we get again their total stake and how much are they contributing to each validator. Because I think good, helpful for diagnostic, but so far it's like if you run it with the default parameters, you're basically recreating what you already have in Polkadot.js app. So most of the valuable use cases come from when you want to increase stuff or when you want to change a parameter. Any questions so far or any?
Yeah, I have one question. Am I right that I could understand that in order to check how many validators are in the network, the tool, you're right?
Sorry, can you repeat?
The purpose of the tool is to check how many validators.
I mean, it's, I don't know really what the purpose. No, like it's to predict. The initial purpose was to predict the validators with a non-default parameter. You know, like if for example the proof of stake is not yet enabled in a chain, which is what we're going to see soon in Polkadot, or if you want to change a parameter. Best example is you want to see if you would be included if we increase the validator size to 300, for example. What would happen?
And it's just the tool. It will be not built in.
No. It's completely separate. It's a separate repo.
Okay, thank you.
Yeah.
Also, so this is like just running this for the current era and like the current state of the chain when running this, right?
Well, no. You can. There is a parameter here. You can pass I think like --@ and a hex of a block number, and then it reads everything on that block number, which is kind of useful because if you even want to try and compare the results of this to whatever you have on chain, you should do the comparison at the first block after the end of error. Because otherwise, for the rest of the time, you have slashing, you have people changing their nomination, everything becomes more complicated. So yeah, you can pass the block number and everything would happen at that time.
So that's like for every block number that's like that's prior to the current block number, right? Like if you give it the block number that's like doesn't exist yet, it won't work. Right?
Yeah, I assume it doesn't. I mean, I must have like some of it in my history. Yeah, I mean, this was a previous run of the same command. So you can pass in like --@ and a hex of some particular block number, and then it runs it on that block.
So we can just like, you know, grab a block number from our node log or like Polkascan or something.
I usually go to Polkascan and I get a block hash from there, and then I test stuff here. This is actually like a common workflow. Yeah.
So it's querying Kusama, I guess, by default. Like I haven't seen you specify an endpoint or anything.
Yeah, so the default is it looks into your local computer, and I now have a Kusama node synced because it's a whole lot faster. But again, you can pass a URI like as such, and it would just be a bit slower, but you can actually see how slow it is. But I mean, it's not super slow, but it's slower. Yeah, it can also connect to any remote node that exposes WebSocket. Or
okay, so default is local node, so that explains why I was getting connection refused because I don't have local node. But yeah, okay, cool. That makes sense. So
another case
right now is just like network, like we're just waiting for that node to respond.
I think so. Or yeah. These warnings are all because of that playground, which is an unfinished file, which I talked about. Is this even correct? Yeah, this is correct. We should be, I don't know what's happening, honestly. It's, yeah, I mean, it works with a remote node as well. It's just, it's slower. But maybe, I don't know. Yeah, it should be fine. It's definitely fine with a remote node as well. Okay. Another detail, stuff are being logged and you can increase that. And one of them is particularly interesting, which is something that we actually kind of stumbled upon with Will earlier this week. Yeah, if you increase the log level, it gives you like, again, interesting insight, which I, as a person who's working on this stuff on Substrate, is super helpful for, like how much time each operation is taking, like if any of these steps is taking too much time as well. But some of it is also relevant for anyone. One of them being this gigantic piece of log. So I hope I can explain it properly. If you nominate anyone in any substrate-based chain, at least with current palette staking, and they get slashed, and then they come back, and you still nominate for them, and your nomination on chain doesn't change at all. It's still in storage. It's not counted anymore if that slash was non-zero. So if someone gets slashed, this is actually a defensive mechanism that we put in place, because most often if you're voting for someone, you're nominating someone and they get slashed, you want to unnominate them until further notice to check if they're actually worthy or how they're doing and all. And how we do it is, yeah, there's like a filter before we run election on-chain or off-chain, wherever it happens, that checks if any of the validators that I, for example, are voting for has had a slash, which was after when I submitted my nomination, that validator is being removed. Did I succeed at making that clear?
So that's what those logs are like. It's one of them says retaining 0 out of 1 nominations. That means like the person got the validator got slashed, and that was this particular nominator's only. So
for example, we have this guy who's voting for 16 people, but 6 of them are actually been recently slashed, and this person is probably not aware of this, and this is actually kind of useful. I plan to build a dedicated new script for this. So you can, like, for example, pass in your nominator ID, account ID, and it checks this or similar stuff for you. And this is something that we could work on today. Another, okay, now let's maybe quickly also look into Council and what's happening there. And what we have in Council is basically a simpler example of what we have in staking. It's just smaller numbers. It gives you 20 elected people as output, and yeah, the first 13 are the actual councillors, and the rest are runners up, or the ones which are reserved. And yeah, we like one other, for example, use case is similar things, like similar checks. We have one for council as well, which is one of the candidates that I was thinking we could maybe work on today, or yeah, or we can even at least discuss it. For example, in the council, we have this notion of a defunct voter, a voter which is no longer useful. If you have set some vote in the council and none of the people that you vote for example, exist, or they're no longer candidates, or they're no longer members, if that's the case, someone can actually report you and you actually get slashed, and that other person gets a reward. And I'm pretty sure no one has ever checked that, probably, in Kusama. And who knows, maybe there's a good business model there. I don't know. I mean, it could be like these kind of stuff. Okay, now maybe I can briefly explain how this tool is working under the hood. I think these kind of stuff are really easy to build. Well, both here, if you want to work in Rust, a code similar to what I'm doing here is a good way to go. Else, Polkadot.js API also gives you a very similar thing. Let's see.
Yeah, for sure. Like I would be really interested in seeing even just how you grab a piece of state off the chain from Rust.
Yeah, I think like I have a storage module here, which I actually want to export. Like I want to decouple it from out of this crate and expose it as another like very tiny, like the storage and the RPC stuff. I want to extract them from this project and put them in another project. It would be like a very minimalist storage API for Substrate, and you can also like make it beautiful and make it work with like macros where you would type like, I don't know, storage, like I don't know, like this, and then just taking dots, I don't know, validators, and then it just reads it for you. I don't know, something which is very, very easy to do, because currently you have to pass in functions and you have to pass in like 3 generic arguments, which you probably don't have to specify in all cases. It's not needed. Anyhow, so the reading storage from the chain all happens within RPC. We have one RPC endpoint, get storage, and super helpful. It does one thing and does it right. If you give it a storage key, it gives you a value. And the challenge now is only to generate that storage key. And to do that, we have the content of this function is just doing this operation. You can also see how all the functions here have this at parameter. So, because all the RPCs in Substrate have the at parameter. You can call an RPC at now or 10 years ago. It's apparently how it's designed to work. I think it's the same in other blockchains as well, as far as I heard. The main gist of this function is perhaps 2 parts. Generating keys. For example, if you have a value, you always receive a module name and a storage name. I can go to, well, we'll see an example as well. And then what you do is you have a hashing, which is sort of a standard mechanism in Substrate. And you have to hash them in a particular way. And then it gives you another hash, which happens to be the storage key. And if you give this to this RPC, you get the result back. To me, on one hand, super simple, but like you already know it. Many of you probably already know it. But once you work with it, it starts, revealing more and more details. You need to have the same for maps as well. So a map is composed of 3 parts, like module name, storage name, and some key, which is the key of the map. Same with double map. Again,
Yeah,
you
let me
just have
ask you about that map one, just because I have like a classic example in mind. So like if I wanted to just check my balance on chain.
Yeah, let's do that. Should we do that? I don't know. We can either do it, or if you give me if you can extract the not the account ID like the SS58, but the other format, like the raw account ID, we can definitely do that in the playground script now.
Like, is it like a public key that you need? I actually don't honestly.
Yeah, I know how to convert them. Yeah, I need a public key because I tried it a few days ago. I don't know yet how to convert SS58 to public key, which is kind of shameful, but I couldn't figure it out.
Yeah, I don't either. You might be able to figure it out.
But
question, you don't have to say yes to this, but if you're in the mood for some live coding, like balance check, or like, check the balance of blank seems like a useful, like, basic.
Yeah. We'll do it now. Let me just go through the storage stuff. I actually know how to convert SS50 whatever the encoding to account ID. I know how to do it in JavaScript, and then we can use the output here. And then you have, there's also one auxiliary function enumerate map, because this one uses a different RPC, and it's a bit more complicated. You first have to get, you give it a prefix. And if you have a map in Substrate, which is placed at some module and storage name, like staking validator is actually a map, you give it this prefix, and then this one gives you all the key value pairs, and then you can enumerate on it. Let's also look at maybe one example of this in, I don't know, staking code, get candidates, for example. You can see we're just calling into that. Let's look at something easier. Yeah, get current error. Storage, read, and you give it, you use that other function value, like the key of a value, and the key should be composed of module, which is staking, it's defined up here, and storage name is current era. If you want to check this, you can go to Substrate. There's a storage in Substrate called current era. The capitalization, of course, also matters, and that's it. The only thing you have to do is, as a generic argument to all of these storage function stuff, you need to give as a generic type the type which we should decode into. Like, makes sense, because the RPC just gives you some bytes. You don't know what to do with it. And you can see how here we are accepting one generic type T, which should be only decodable, and at the end, whatever raw data we get, we try and decode it into that T type. And okay, let's try and read a account balance, I guess.
Okay, cool. So now you're in this playground file, and I was just reading your docs. It sounds like playground is this spot where you just write some code and then it gets run.
Yeah, it's I added it a few days ago, mainly as a preparation for this talk. So let me see can you see now my editor, or what do you see here?
Yeah, VS Code.
No, okay, so that's the problem, because I'm now looking at other stuff. So we need an account. So let's do something simpler. We have accounts here. Which one do you like? This P2P guys? They look good.
No, I hate that guy. No, just kidding.
Yeah, let's go for this. And I think we need to use this hex macro as such. Let's. And what type does this give me? Yeah. So, to read the account balance of an account, we need to tap into one particular storage item, which is located into a system module. I can peek into it here without changing my screen, I hope. I just do this with no particular purpose, and then we use the beauty of Rust Analyzer. And what was the name? Account data, I think. Yeah, there it is. Yeah. Yeah, I actually did this a few days ago, and I deleted the code. And it's quite, like, you have to do a few hops of decoding and everything. So to read an account state info in general, and this is like one map which holds a mapping from account IDs to account info, and then this account info struct has a nonce and has a reference count and has a data, which is a generic thing called account data, and then we have to go back again into where we were before.
Yeah, I forgot this is kind of roundabout. I think in a previous iteration, this was just like a storage map in the balances path.
Yeah, now it's a bit more complicated because we wanted the nonce of an account and the balance of an account is almost always touched at the same time. You always increment the nonce and you pay some fees. So this puts them in the same spot. So the thing that we were looking for was the second generic argument to account info, which is t.account info. So again, we go back up like this. You have to just, yeah, drives you crazy. Type account data, it's some generic thing that this guy receives. And it comes from the balances module. Well, I can show this as well. Can I?
Is it a better, more practical idea to like look up an account nonce so that we don't have to do that second
Sure.
jump?
Yeah, we can do that.
Step.
Yeah, we can do that as well. So let's first check if everything is working fine. And what do I run? Yeah, and let's maybe. I mean, I'm a debug freak. I want to run these as much as possible. So to read the nonce, we only have to look up the account. What was the string? So the name of the storage thing is account. So what we would have to do is say storage read for me. And the first thing, the second thing and the third thing that we have to pass in are rather easy. Client stays client. It comes from the top level module gives you a client. The @ needs to be a block number, but this scripts that I composed here give you always a config, which is that top level configurations that you pass in, and this gives you actually a block hash as well. And if you don't pass it in, it always fetches the latest block hash. You can also see it here in my previous run. It already said I run everything at this block hash, even though I didn't really tell it anything. So I would just use this, well, cc, let's call it better command config. I think that's the. So we have these two guys settled. And now what we need to pass to read is a storage key, which we build with those auxiliary functions that storage module also provides to us. What we're trying to read now is a map. So we need the key of a map. The module name is system. Like this is what I said I would like to wrap in a macro, because now you have to like do these nasty stuff and it's like not pretty. Account was the name of the, was it account? Was it accounts or, I mean, we can double check. Yeah, it was account. And then as the encoded key, we need to pass a Blake 128 concat hash of the account ID. Now, what we have here is the account ID in a very nice shape that I printed. It's the exactly byte encoded. And but the thing is, these map functions as well are also generic over a hasher type, which can be anything, which can be just a storage hasher. And to make things easier here, I imported some useful stuff from Substrate, and I put them into this primitive files that I have, including account ID, balance, blah, 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 and the two hasher types that we use all around the place to make things easier. Although I'm not sure if this is actually what we would be using. Let's look at an example here from staking. Map. Yeah, okay, no, I import them directly from frame. Okay, so never mind, just forget what I said. So we need to pass a generic type to map key, which is the hasher type. And so we import that from frame support. And the hashing type, we just looked at it, was Blake, this guy, this Blake 128 concat. Again, ugly stuff, which, as I said, the first time that you go through it teaches you a lot about the details. And as the encoded key, we can just pass in the account. So, and not done yet. What is this? This is the, let's call it account data. So this read function itself is, again, generic over some t, which is decodable. And by standard, well, you can pass it either here as a generic type, or you can pass it here as a type. But I prefer this one for now. And what this needs to be, we can again double check in the other file, is merely the storage type which you're trying to decode. So again, well, this time we literally have to import system. And well, this is one place where working in Rust becomes kind of easier, because for all the types, you have access to the real thing. You know, you can just you can look at the real type and you can infer stuff. So this account thing, we need to import.
Like working in Rust, that's better than if we were like working in JavaScript, where we have to like redefine all of our types and everything.
Well, the JavaScript API also gives you all the type, but there are like, you know, I think this is more, I mean, for me as a Rust developer who's working on Substrate, this is like way more informative. You know, I can see how everything is working. Mm-hmm. Everything falls into one piece, and then I'm like, like it works. But when you work in JavaScript, it's like a black box, and by no means I'm saying that like that's good or bad. Like I just think this gives you also like some good lessons, mostly headache, but also some good lessons. I mean, we're going to fall into one of those headaches now, because I'm not sure how I'm going to get this index type and accounts data type. Okay, so whatever we're trying to decode is this account info struct in system. Let me do something else. I can bring this here. Now you can see another substrate, right? This is my,
We only see one window.
Oh, really? Okay, never mind. So what we're trying to import is this account info, which is a pub struct in system. So no worries, we account info. The other things that we're going to be needing. So, and this is what we're going to be decoding, and this is what we have to pass in here. Account info, but well, damn, this is again generic. And the first thing is an index. The second one is an account data. Let's look where they come from. I can still show them. So the account, the first one is an in. Let's see. Yeah, we can just go into Kusama runtime and system trait. You can see when we are implementing system trait, we have this thing called account data, which was the thing that we were looking for in the other file. And this is coming from balances. I hope this is it clear? Like, is this, like, this is kind of hard to show on one screen as well, you know, everyone. So the thing in system,
I mostly get it. Like I get that thing where we're trying to decode these bytes that we get from the RPC, and we know we want to decode them into an account data, and we know that, or an account info, and we know that it has its own two generic params, which you're trying to affect.
And the second one,
sorry, go ahead.
The second one is an account data, which comes from a type account data, which is defined here. Type account data, and this is what I showed you here now. Now remember this, like remember this line, and then so that one last time, type account data in the system trait, and then if we go to Kusama runtime or any other runtime that you like, let's look at type account data. See, it's being fulfilled by balances module. So to properly, and the first thing is index, which is being fulfilled by this guy, which, what is this nonce? It's just U32. Yeah, I'm going to just pass U32 manually. I mean, you can do it nicer. So the second generic argument, long story short, is account data. I mean, it's already imported because I was working on it actually a few days ago. So account data. And the account data itself is still generic over another type, which is the balance type. But this gets easier at this point. I mean, we know we now have this primitive thing of our own, which is importing some stuff from, this is actually Kusama primitives. It's I renamed it to node primitives or whatever. I mean, we know that balance is always U128. You know, you can at this point sort of ascend from all that generic stuff and make assumptions. So well, actually, it's nicer if you call it just balance. But this balance that I'm importing is merely U128. It's not a big deal. And I think that's it. Well, this was a very bad example because it showed how hard it is to do it, not really how easy it is to do it. But I mean, okay, I'm forgetting this here. And what else? I think this needs to be like, what is the error here? This needs to be like as such. And I think this should give us, I mean, well, what? This is, yeah, all of these functions are async, so you need to await on them.
So all this, it's kind of like a nice opportunity to appreciate the frame macros. Sometimes I curse those macros because I'm like, I get crappy error messages and I don't know what's going on behind the scenes, but it also is like abstracting away this business about having to hash all this stuff together and get the bytes in the right order.
Yeah, exactly. I mean, everything that declare module is doing is just giving you a nice abstraction around hashing storage together. And so we got this guy's balances. I mean, you said only nonce, but we eventually had to do the second hop as well here. So we get this guy's balance. And we can, like, once you get used to this, what's the saying? Like, your imagination is the limit. You can play all sorts of game with the chain, and you can, like, I think I mentioned a few examples. You can find, like, if your nominator is doing well, we can write a script for that. You can, I mean, you can also do all of them in JavaScript again, but yeah, this is in the context of this tool. You can find those defunct voters and actually get them stashed and maybe earn some money.
Yeah, it's pretty. So I mean, like, when you were doing this tool was originally for offline fragment, right? And you showed us that first. And so basically you did maybe one or several instances of what you just showed us, like grabbing data from the chain and then applied the algorithms that you had already written to run fragment on that data, I guess, right?
Yeah, I mean, now having seen this, if you look at like this code here, which is everything related to staking, I mean, it is very long, but end of the day, it's not doing anything different from what I just showed you, except for, but it's now reading more stuff and doing more stuff. But like the gist of it is always the same. You just grab some data and then you apply some whatever you want on it. So, like, for example, one other thing that you can do, these are ideas that you can implement basically on any API. It doesn't really need to be this. No, we have the same thing on staking as well, where you can reap an account. You can report an account to be dust, basically. If their staked value is below a certain amount, they are considered dust. You can easily write like a bot here to like do that for you, and just find accounts and report them. Again, you get some reward if you do it. Tracking your balance is also interesting. Like if we run the same thing and then we just tweak this where's this? Where's the at? Oh yeah, this guy. If we tweak this and then we start from the latest finalized head and just loop to the parent hash, all the way down, you can just see how your balance is evolving. That's also super interesting. All the stuff that I never done myself, but I would, at some point I thought of them either for myself or for someone else when something asks someone. Let's see. Yeah, of course, back to the original idea, you can also do quite a lot still regarding staking and fragment as well. Like you can incorporate the reward mechanisms here as well and have a genuine reward prediction, because I mean we have online tools, but I doubt and they work. I have tried them myself and I've looked at the results, but I don't know how they get like their prediction. It's probably I don't know how they do it. But I mean, this is the real thing. Like the good thing here is you have access to the substrate source code. You know, you can, and some stuff that are not implemented in any API, you can now play with them. I can call into staking module and call the reward function of a particular hypothetical error, and then actually see what the outcome would be, and then I can brute force that and see who am I going to vote for to get the best results. And yeah, these are some of the ideas I had. One other thing that I wanted to show was, let's make this sort of bigger. Wow, that's too big. How do I bring it back? Oh, okay. Back to staking, and yeah, let's work with count 10. And so I want to run one example and then run it with reduce and show how it affects a lot of stuff. So I can make this probably info now, and one more time. So now we have a bunch of winners, and you can see they have quite a lot of voters, like each of them. But I mean, I'm not sure what the result would be. Let's run it with reduce, see what happens. So the reduce is going to try and remove as many edges as possible. And for example, this first one, Web3 Italy, they have 76 voters here, but here they had 211. It's the same account. But this is one sort of demonstration of this reduce and how it's working. And I actually have an assertion somewhere in the code, because I get this quite a lot, that okay, I don't know where it is, but I have an assertion somewhere in the code that once we apply this reduce, this total backing stake of this Web3 Italy, for example, it doesn't change. It's what, 261 something KSM, and up here as well is 261 something KSM. So we're basically removing edges without changing the backing stake. What else? One other thing that you can see, and it could be interesting, is I think it's like this post-processing iteration. If you run number of iterations, it's going to try and equalize the stakes. And what most often happens is that it increases the minimum selected validator. So in this case, the minimum selected one happens to be this last one, which is also the first element in this core log that I have here. Like this 236 something KSM is the stake of the weakest validator that we elected. And this is quite interesting in most of the cases, because this indicates the security of the system. If the weakest validator is very low, like they're very cheap, they're more likely to be malicious. So now let's run 10 iterations of that post-processing that I talked about, and I hope it changes something. I mean, we have a log here that says we ran equalize and we improved slot stake, which is another name for that minimum thingy, by quite a lot, actually. Wow, is that true? Okay, 278,000 KSM, and what was it before? Wasn't it the same? Okay, 2,000. Okay, yeah. So you can see it increased this one. It increased actually the minimum backing stake. Some detail probably more related to validator community. Okay, I'm open to suggestions and questions, but I'm more or less done. I think that's enough.
So is the point of reduce just to increase that minimum stake?
No, equalize. That's called equalize or balancing. That's the name of it in the literature. Reduce just reduces the size. Reduce
like,
was,
you mean, right? Like transact when you go to submit the solution to on-chain, you want it to be as small as possible in terms of like
reduce is about the difference of these two lines. Like this tiny solution that I generated here, I mean, it's only 10 validators, but because they all have tens and hundreds of voters, it's still quite big. It's 39 kilobytes if you encode it. And by encoding, I literally mean parity scale coding it. But the reduced one is 2 kilobytes. And because the reduced one, it's currently enabled actually. Yeah, now it's going to be, the difference is even going to be more. The reduce just reduces the size. It doesn't change the stake of the validators. It does change. So the thing that happened when this was released was many of the nominators who voted for dozens of validators had all of their stake going to one of them. Now, because if I vote for 16, the other 15 get removed by this reduce process. And it's not really this is very beneficial for the system. Like the rationale at the moment is that this is very beneficial for the system because it drastically reduces the transaction size. And if you're really keen on distributing your stake, you can always just create multiple accounts and yeah, do it that way.
Yeah, I think, isn't it the case that the semantics of nominating are that you're basically casting approval votes? Like I would be willing to put my nomination stake behind these people, and it doesn't really like guarantee that it doesn't entitle you to all of them or anything.
Yeah, I think, yeah, exactly. So far, it kind of did because Fragment is a bad algorithm, and because it's bad, like it's weak, the sequential fragment, like the plain one, because it's weak, it doesn't split the stakes properly to get a good outcome. It's because already with sequential fragment, you have no control over how much of your stake goes to someone. You can only say I vote for A, B, and C. But Fragment might decide, okay, I'm going to get 90% to A, 5% to B, and nothing to C. Oh, no, okay, no, that's not 100. 90, 10, and 0. Fragment could decide that. But the thing is, the sequential fragment never decides that most often. It creates like uneven distributions, but it gives everyone something, which is not necessarily good. And I think I would do probably like another, like there's more. Like I recently was briefed by Web3 Foundation that it's going to be changed again. Like we're going to change quite a lot again. Like this election stuff will change again pretty soon. So I would probably again come to another seminar soon and explain them once they're done.
All right, cool.
Okay.
Yeah, thanks a lot, Kiana. Hey, I really appreciate you coming on and keeping us updated on all your work on Fragment and the various
it's
go with it.
My pleasure. Thanks. Thank you.
The repo that I want to show is this one. It comes from this org, Substrate Developer Hub, which is where we have all of our docs and tutorials and stuff for Substrate. And this particular one's called Recipes. And so the recipes is basically my attempt to build a bunch of working examples, some of them practical and some of them more like minimal and educational, of stuff that you can build on Substrate. And there's basically 4 folders, and consensus is really small. I just added that one. That's where like consensus algorithms go, but we only have one right now. But the other 3 folders is a bunch of nodes, a bunch of runtimes. So like every node has a runtime, that's its business logic. And then most runtimes are built with Frame, this like paradigm for building runtimes. And when you build them that way, you include individual palettes in them. And so that's why, so we have those 3 like levels of Substrate. Let me make that a little bigger. So nodes, runtimes, and palettes. Somewhere in here, I actually have a diagram. Let me show that. This one. Yeah, anyway, so like the entire thing that we're looking at here is a node, and then the runtime is this business logic, and then inside of there, there's you can put particular palettes. And so, you know, I always saw diagrams like this in presentations and everything, and I had this idea. I was like, well, it would really be cool to be able to write a bunch of different nodes and a bunch of different runtimes and be able to like mix and match them, like swap one runtime. You know, maybe I want like the Polkadot runtime, but on a proof of work node, or maybe I want like something that's a lot like Bitcoin, but I want it on like a proof of authority node or something. And so that's one of the things I set out to do here in the recipes. And so maybe I'll just show you an example of that. Let me switch to my editor instead of GitHub. Okay, so here we are. There's all those same directories, nodes, runtimes, palettes. And here we go. So I'm just looking at like, let's just choose one of them, the basic proof of work node. And in its cargo toml, like you have all of these dependencies. This is totally normal. Like all this stuff comes from Substrate. And it's really cool now that Substrate is publishing on crates.io. We just have these really nice normal looking Rust dependencies where you just specify a version and that's it. So I was really excited when we got to that point with Substrate. And then there's this last dependency, which is the runtime, and it doesn't come from crates.io. It just comes from somewhere else in the recipes because I'm choosing to use my own super runtime here. But the thing I wanted to show here is that it's extremely easy to just say like, oh, hey, I'm not really in the mood for the super runtime. Let me just like comment that out and include this other runtime, the wait fee runtime, or this third one, the API runtime. And each one of those runtimes demonstrates its own like useful, you know, whatever it is. Like this wait fee one demonstrates how you convert weights into fees that'll actually be charged in token balances. And the API runtime shows how you add a custom runtime API so that you can like extract specific data out of your runtime that's, you know, that's unique to your chain. So this was not super possible with like, maybe you've encountered the Substrate node template or something like that. And the problem is that, actually there's one really similar here, the Babe Grandpa node. And the problem with a node like this is that, well, it's not really a problem. I mean, it does a really cool thing. It does this thing where like, this is a proof of authority node, basically. Like you have Babe authorities for block production and Grandpa authorities for authoring. And the cool thing that it does is it extracts the authorities out of the runtime. And that allows us to say like, you know, this isn't just regular old dumb proof of authority with a hard-coded list. It allows us to use all those tools that Kian was just telling us about, like staking, for example, to turn our proof of authority into proof of stake. So it's really cool, definitely. But the problem that comes up is if your runtime is written to be used in one of these chains, then it has a palette, like in this particular one, it has like the Babe palette. And that Babe palette has some expectations of information that the node will provide. Like basically every node, when it authors a block, it includes this thing called a pre-runtime digest, which is just a little piece of information that tells the runtime, specifically tells the Babe palette, like, hey, this is what slot this block was for, and I think maybe a couple other pieces of information. The details of what's in it are not really that important. The problem is like, if you write your runtime expecting to use this Babe palette, you can't do the mixing and matching like I was demonstrating before. So I recently refactored these runtimes to be like as minimal as possible, or like the minimal one is the standard. And then when you want to do something sort of unique and special and cool, like pull your Babe authorities or your Grandpa voters out of the runtime, then we specifically demonstrate that. So, so that's like just one thing I wanted to show because I think it's kind of a cool idea. But then the one particular thing that I wanted to dive into today was this recipe that I recently wrote called Hybrid Consensus, and it lives here in the nodes folder. So maybe we'll just look at its dependencies first. Yeah, right. So the runtime, this is one of those ones where you can't use an arbitrary runtime. It does something special. It actually pulls a set of Grandpa voters out of the runtime. And so I just used this minimal Grandpa runtime. So there isn't really anything special about this runtime except that it uses Grandpa. This node could be used with any runtime that has the Grandpa palette. as long as it doesn't have any of those constraints I said earlier where it like expects babe pre-digest or something. Okay, so anyway, here's the point. Here's what I do in this recipe. I basically cribbed the design from the ETH2 spec, which I think is cool and unique. And what it does is it says, we want to use proof of work for our block authoring. And so we use like the POW module that comes with Substrate in my implementation here. But it also says that lacking deterministic finality kind of sucks because you never know for sure like this transaction went through and won't be reverted. So in the ETH2 spec that I add on top of it, like this finality gadget called Casper FFG, or the Casper the friendly finality gadget. And that Casper FFG is not written in Substrate, but we have an analogous thing called Grandpa. And so what this recipe does is it uses proof of work for block authoring, and then it uses Grandpa voting for deterministic finality. So you still have to solve a proof of work to author a block, just like in Bitcoin and Ethereum. But then you don't have this property where the chain can be reverted arbitrarily long into the past. You know when something's finalized, just like you would on, like Polkadot, for example, or Kusama.
So are the miners going to be the same people that are going to be like performing the finality stuff? Like, are the miners the same as the validators?
That is something that I hope to do in my next recipe. So, or in a future recipe. Yeah, like some ideas I've experimented with are like the miners from the last like N blocks, I don't know, like 50 maybe, will be like the Grandpa voters. And then I don't know if it's a good idea to rotate them every block. Maybe that's fine. Or maybe it's more like, okay, for this period of 50 blocks, the miners from the previous 50 are the Grandpa voters. Like, I think that's a totally cool thing to do. And I even think it's like, I have the design in my head, but I haven't coded it up. So in this particular one, the miner set is totally permissionless as usual. And then the Grandpa voters are pulled from the runtime. And so like, from the node's perspective, that's totally abstracted away. Like, it has no idea how the runtime is determining the Grandpa voters. It could be through staking or something like that. But in this particular minimal Grandpa runtime, it's just a fixed, it comes from the Genesis config and never changes. Yeah, good question. Basically, the interesting part of the code happens here in the service builder. And I've talked about this on seminar a few times, but I know it's kind of like a intimidating piece of the code. And so I'll just give the overview again real quick. There's basically 3 big chunks of this file. The first one is this macro called new full start. And the second one is this function called new full. And the third one is this function called new light. And that takes us all the way to the end of the file, okay? And so what happens is new light stands on its own. That's the way you build a light client. We're not going to show it here. New full is the thing that builds, a full node, a regular client. And after just like making a couple local helper variables, the new full, basically what it does is it calls the macro new full start, which we saw above. So those first 2 blocks flow together in order, starting here all the way through the macro, all the way through new full, and then by the time you reach the end of that function, you've built a full node. So this is the part where it starts to get interesting. Like, many of these things are unchanged. We're using the longest chain rule, like pretty much always, and nothing too interesting in the transaction pool. We just use a regular one. But the import queue is where things start to get pretty exciting. And so what we do for the import queue is, well, maybe what I should talk about first is this thing called like the block import pipeline. And so when a block comes across the network, it goes to the block import queue, and then the import queue has it, passes it off to each layer of consensus to get individually verified. And then finally it goes to the substrate client where it gets imported into the main like database. So like, I guess we can start here. I create this instance of Grandpa block import, and this is a thing that implements a particular trait. The trait is also called block import. And basically block import is responsible for doing some like verification and checking. And it's also responsible for like letting each consensus engine update its own little, like, I think they call it an auxiliary database if the consensus engine has any like bookkeeping or note taking to do. So we create one for Grandpa, great. You can see we give it here this client. And so like in terms of the block import pipeline, the client is the end, or like I heard Rob describe it as an onion. So the client is like the center of the onion, and I've wrapped it with a Grandpa block import. And then down here, I create a POW block import, and you can see I give it a reference to the Grandpa block import. So that adds like another pipe in the pipeline, or another layer in the onion. So from outside in, we've got POW block import. That's going to make sure that like the mining work has enough, you know, that meets the difficulty requirements. And it does do some bookkeeping, but I can't remember what it was. I'm not sure I ever understood that part. And then moving in, we have the Grandpa block import, and then moving in, we have the client. And that's where like the block database lives. That's the final destination. So once we've created those two things, now we're able to create the import queue. And you see that I just give it this reference to the POW block import. And that's it. I don't need to give it a reference to the Grandpa block import, because like really this is referring to the whole pipeline. Like the import queue gets a reference to POW block import. It itself has a reference to Grandpa block import and to client all the way down.
What would Grandpa have with, I can hear myself. What would Grandpa have with block import? Because when we're importing, we're not really caring if it's finalized or not, right?
Yeah, so that's right. That's a good question.
Yeah, because I think we do the same in Substrate as well. Pretty sure. Like it does some check, but I'm just curious. Like I don't see what would Grandpa have when we. But probably block import is doing more than just import. Maybe, I don't know.
Yeah, it's a good question. Let's check it out. For sure, the import queue does more than just blocks. It also imports like finality proofs and stuff like that. So definitely Grandpa cares there, but I don't think that's true for the block import trait. So like, let's just see what it does. Here's the part that I was looking at where we impl block import for Grandpa block import. And here's the like main function import block. So exit early if block already in chain. Okay. Oh yeah, this is totally it. We're checking for authority changes. So Grandpa allows, in Substrate, allows the notion of like switching the authorities. And so that information is included as a digest item in the block header. Good question. There might be other stuff too. I'm not really. Restoring old authority set. Force change. Yeah, it seems like it's all about handing off authorities. So, okay, cool. So that's all about like the block importing stuff, but then we still have to do all of the like authoring and setting up the Grandpa voter and everything. So, okay, so now we're into new full. Again, like that seam between the macro and the function is really not very consequential. Don't even worry about it. Okay, here we finally build the service. So that part's done. Like our service is all constructed now. If we're an authority, then we create this proposer factory. I can't remember exactly what that does.
Yeah, proposer authors blocks actually. I think we talked about it in a few weeks ago when we were talking about the instant seal and stuff. Like the proposer is the thing that builds a block. The naming is a bit different, I guess. But it's what you said earlier is also totally true. Like the flag is dash at validator, but the Boolean is authority, I think.
Yeah, you can see it checking like role is authority. Yeah, exactly. Okay, so we create this proposer. Oh yeah, I do remember. I think you made that observation a few weeks ago too. Like the consensus engine dictates when you can build a block, and the proposer is the thing that does the block building. That sounds familiar now. Okay, cool. So we build it here. And then here's where we do call like start mine. And oh, and I will say with POW, this is it. Oh yeah, go ahead. Oh, did somebody have a question? No, maybe not. Sorry, I thought I heard someone talking. So start mine, like with POW, is a tiny bit different than most of them. Like in Aura, Grandpa Babe, pretty much all of these things, what you do is you create like an async future, I guess, and then spawn it in its own, I don't even know the vocab, but like that future is running. With POW, it's different because it's like, you know, CPU intensive. It's supposed to just keep chugging and chugging and chugging, going as fast as it can. So in this case, we don't get back a future or anything. This thing actually spins up its own whole thread in the background. But even the docs for start mine say like, this is special for POW for that reason. It's not like the standard design. And so this is basically this is the call that says like, okay, node, you're a miner, go ahead and start mining. And then so like down here, so we create this grandpa config, and then, you know, so here we have another thing we'll check, like if we're a grandpa authority. To be honest with you, I don't know exactly. I think there's a flag called like disable grandpa or something like that. And otherwise, if you give it validate -- validator, then you become a grandpa authority. Where did we create? Oh yeah, so we do it right in one line here. So this is where we say like, this is the more normal one where I was saying like this run grandpa voter, this is like in some ways analogous to start mine. Like it's you know, it's the thing that's supposed to cast finality votes and listen to other finality votes and that kind of thing. But in this case, we do spawn it just as like you know, it's an async worker. It doesn't get its own thread. And then there's this, like Andre would be able to answer this a lot better than I can explain it, but there's, for some reason, if you've disabled grandpa, you still have to set up this, like this disabled grandpa thing. And the docs basically say like, you have to tell the node what to do when it receives incoming grandpa votes, and it basically just like throws them away and ignores them. The exact reasons why that's necessary are not really clear to me. But yeah, I mean, so that's basically it. And I wired this thing together by just stealing code from like, you know, the Polkadot node or the substrate node, which is really similar. It just, instead of POW, it uses, you know, Aura or Babe, depending on which node it is. And then the POW stuff is already like demonstrated in basic POW or in Kalupu. And so like, that's one of the things that I think is kind of cool, or that I'm trying to demonstrate with the recipes, that like substrate super modular, I can pull a piece from here and wire them together and make a chain. And the way I like to show the demo, and that I had done it originally, is that you get your network up and running with a single miner, blocks are producing, nothing's finalized because you have specified 2 grandpa voters and you need 2/3 of the voters to finalize. So then you bring your second miner online, and now you have 2 out of 2, and so everything gets finalized. And then you kill one, and you continue to author more and more blocks, but again, they're not being finalized. So that's what hopefully we'll get to show. So let's see if this worked on Alpha 8. Target release hybrid okay. Yes. Okay, cool. So that looks good. So since dev worked, so yeah, in a pure POW network, dev isn't really any different than anything else. But in this hybrid consensus one, it is, because in dev you only have 1 grandpa authority, and in, you know, local you have more. So let's just try this. Chain local, base path, temp, Alice 1 2 3 4. And we'll make her a validator. And we'll give her keys. All right, and then we'll do similar thing, target release, hybrid consensus, chain, local, base path, temp, Bob, 1 2 3 4, and we'll give him validator, and we'll give him Bob. But I'm not going to start him yet because I want to find one of these messages that shows that we have 29 blocks and none are finalized for like all the reasons I explained earlier. And that's continuing to happen. Like they mine fast enough that it's hard to spot those logs, but now we're up to 53 and nothing finalized. And so then when we start Bob, whoops, validator. Yeah, oh, cool. So look at this. Bob was mining his own chain and he got up to block, looks like he got up to block 7. And then he finally discovered Alice, and he, like, here it says reorganized up to 65, which Alice had mined. And then let's find one of these bad boys. Here's one. So now they're up to 91, and like, I guess they've gone through enough rounds of grandpa, it's catching up, and they've finalized 74, and it should be even lower as we go. Let's see if there's another one. Ooh, interesting. It seems like finality stalled. I wonder why that happened. Let's see what Alice says. Oh, wow. Ooh, that's interesting. It almost seems like they, I think this is the message that Alice gives when she's like undergoing a major network sync, and I'm not really sure why that would have happened, but like if she paused her grandpa voting operations because she thinks she's syncing, that explains why we are no longer past 74. But oh, I wonder if Bob is authoring blocks so fast that Alice is just like always syncing. That doesn't seem right because she's only at block 76. Let's just kill her and try again. So she's mining again now, but not at the right tip of the chain. She just picked up where she left off. Oh, that's because she didn't peer yet. Yeah. Oh, okay, so here's an interesting thing that happens. Timestamp too far in future. So this happens on proof of work nodes when you set your difficulty too low, because my runtime has the timestamp palette, and the timestamp palette has this logic that says like there's a certain minimum period between blocks, and you set that in your runtime. In fact, I'll just show it real quick. Minimal grandpa runtime source librs timestamp trait. Yeah, right here. So I set it to be 1 second, 1,000 milliseconds. And so if blocks come faster than that, then your node, as it's mining, it knows like, oh crap, this one came too fast. And if I send it out, it's going to be invalid. So it actually does this thing where it says like, let's just say it came 1/3 of a second later than it actually did. No big deal. And so it's valid. But if you do that enough times in a row, then all those drifts add up. And there's other logic in the timestamp palette that says, if you get a block that says it's more than 30 seconds in the future from what your node or your like local clock says, then, you know, reject that. So that is what this is all about. Let's see what happened. Oh, look. Oh, wow. So they peered. They're up to 260 and basically finalizing. How's Bob doing? Let's see. It's hard to see when it's moving. Oh yeah, so it seems like it's working now. I'm very curious what this major sync was about. I'm glad I have these logs. But yeah, so okay. Anyway, we're like at the end of the seminar, so I'll just, I guess, take any questions, and then otherwise we can wrap up.
That's a cool demo.
Yeah,
it's good to see that stuff.
Yeah, nice. Thanks a lot. Okay, cool. Thanks a lot, Kian, for presenting Offline Fragment, and everybody for coming to the seminar again. I think we have a topic scheduled next week. One of our colleagues, Maggie, is going to show how to make a substrate node with alternate crypto. So I think like out of the box, there's 3 curves that are supported, and she's added a 4th one. But I think after that, we've got some available seminars. So if you have something that you want to show, or even a topic you want to request, you know, you could do it now, or you could do it in Riot, or yeah, however.
Yeah, thanks guys.